Hi everyone! This week we're taking a break from quadratic functions and talking about radicals. We're going to need to use the skills that we learned this week later on this quarter, and also you're going to be using them a lot next year in geometry. Today's learning goal is simplifying radicals. Radical is another name for something that contains a root. A square root, a cube root, a fourth root, any kind of root can be called a radical. So a term that has a root in it, the whole thing is called a radical. When we look at this, we have two radicals here. This is the square root of 60, and this is 5 times the square root of 72. We're going to simplify both of those and two other examples. When you simplify, the thing to keep in mind is that the opposite of square root is squared. Square root and squared cancel out. So for example, if I had the square root of 5 squared, the square root and the squared would cancel out, and that would just give us 5, which makes sense because 5 squared is 25, and we know that the square root of 25 is 5. The reason why, though, is because we can turn 25 into 5 squared, and then the squared and the square root cancel out, just leaving us 5. So the simplified version of square root of 25 would be 5. Simplifying radicals means you're eliminating anything that could be squared, and you're bringing it outside of the radical sign. In order to do that, we first break down any numbers underneath the radical into multiplication problems. So for example, 60. I'm going to think of any multiplication problem that gives me 60. Any multiplication problem you come up with works. You'll get the same answer even if you don't start with the same numbers. So I'm going to use 6 times 10. 6 times 10 is 60. I'm going to break those down now. I'm going to cross off 60 because I broke it down into 6 times 10. I'm going to keep going if I can break things down more. So 6 I can break down into another multiplication problem. 6 is 3 times 2. I'm going to cross 6 out because I broke it down, and now it is 3 times 2 instead. 3, the only multiplication problem that gives me 3 without using a decimal or a negative would be 3 times 1. I don't want to keep going when it's only 3 times 1 because it would just keep going forever. It would be 3 times 1 and then keep going, 3 times 1 and keep going forever. Once you're at what we call a prime number, which means the only way to break it down is doing times 1, then we stop and we box that number. So we're going to box 3 and we're going to box 2 because they're both prime. Now we're going to come over here to 10. I can make a multiplication problem that gives me 10. 2 times 5 gives me 10. Since I broke 10 down, I go ahead and cross it out. And I have a 2 and a 5. So really, square root of 60, I'm going to write them in order from lowest number to highest number, is 2 times 2 times 3 times 5. If I multiply all of those numbers together, it would give me 60. So I haven't really changed what's underneath the radical. I've just written it as multiplication instead of as 60. Okay, the reason I do this is because what I'm really looking for is things that I can write as squared. So for example, 2 times 2 can be rewritten as 2 squared. So I can rewrite this as 2 squared times 3 times 5. Okay? I can break this down further. This is the same as the square root of 2 squared times the square root of 3 times 5. I can just break it into two different kind of problems. The reason I'm doing that is that I can simplify this part, because my squared and my square root will cross off. So the squared and the square root will cross off, leaving this as just the number 2 with no radical sign. Over here, I don't have any exponents to cross off my square root. So that's going to come down here as 3 times 5. Then my final step is I'm going to multiply that 3 times 5 back together. So simplified, this would be 2 square root of 15. And that is the simplified version of square root of 60. I know it's a lot, so let's look at a couple more examples so that you can kind of see how it works again. Okay, so our next one is 5 times the square root of 72. I'm starting by breaking down 72, which is 9 times 8. Since I broke down 72, I cross it out. I can keep going with 9. I can break it down into 3 times 3. Since I broke it down, I cross it out. 3 and 3 are both prime numbers. They can't get broken down anymore without using a 1. 8 can be broken down into 4 times 2. Cross that off. And then 4 can be broken down into 2 times 2. And I'll cross that out. So this is now 5 on the outside. On the inside, I'm going to write them least to greatest. I have 3 2's, 2 times 2 times 2, and then 2 3's, 3 times 3. Okay, so here is the key. I don't want to use any exponent. I only want to use squared because I have square root, and the only thing that crosses off square root is squared. So even though I have 3 2's here, I'm not going to write this as 2 to the third because 2 to the third and square root don't cross off. Instead, I'm going to group 2 of them and just make that 2 squared, and I'm going to leave this 2 alone. Over here I have 2 3's, so that's going to be 3 squared. So now this is 5. I have the square root. I'm going to put my squareds in front. 2 squared times 3 squared, and then I have that extra 2 that didn't have a partner, so it didn't become squared. Okay, I'm going to break this down. I've got 5. My squareds are going to be in 1. My alone one by itself. These will cross off. The squared and the square root go away. So I'm left with 5 times 2 times 3 on the outside with no square root, and then a 2 on the inside with the square root. I'm actually going to multiply these together. So 5 times 2 is 10 times 3 is 30. So this, simplified, is 30 times the square root of 2. All right, let's look at more examples. Okay, our next example is negative square root of 140 x to the third times y. I'm going to go ahead and break this down. So 140 is 2 times 70, and 2 can't go anymore. I'm going to cross out 140 because I broke it down. 70 I can break down into 7 times 10. Cross it off because I broke it down. 7 is prime. 10 I can break down into 2 times 5, both of which are prime, and cross off 10 because I used it. I broke it down. Okay. When I write this out, from least to greatest, I have 2 times 2, because there's 2 2's, times 5 times 7, and then x to the third is really x times x times x. There's 3 of them because it's to the third, and then I have a y. So that's this problem. When I look to see what I can group, I have 2 2's here, so that's 2 squared. I have 2 x's here, so that's x squared. Nothing else has a pair. So I'm going to rewrite it so my squareds are in front. I have 2 squared and x squared, and then I have left over 5, 7, x, and y. 5, 7, x, y. I'm going to split that into 2 pieces, one with the squareds, one without. So I have 2 squared times x squared times 5 times 7 times x times y. Again, the whole point of doing this is that squared and square root cross off. So this is just 2x with no exponents and no square root sign. And then square root of, I'm going to multiply these together. 5 times 7 is 35, xy. And that is the simplified version of this. Let's look at our last one. So our last one is a fraction. And when you have a fraction, you just break it down into two parts. So I have square root of 50a and square root of 64. And I'm just going to put a slash in between them to show that one of them's the top of the fraction and one of them's the bottom. Okay, we're going to break them down separately. So 50 is 25 times 2. Broke it down. 25 is 5 times 5. And I broke it down. So square root of 50 is really square root of 2 times 5 times 5 times a. Don't forget the a that was originally there. These make 5 squared. So this is square root of 5 squared times 2 times a. Break it into two pieces. The square root and the squared cross off. So this is 5 square root of 2a. That's the top of my fraction. Looking at 64, square root of 64, I know 64 is 32 times 2. 32 is 16 times 2. 16 is 8 times 2. 8 is 4 times 2. And 4 is 2 times 2. So I actually have 1, 2, 3, 4, 5, 6 2's. So this is 1, 2, 3, 4, 5, 6. 6 of them. These ones make 2 squared. These ones make 2 squared. These ones make 2 squared. Remember, we're always looking for squared because that's what undoes square root. So I have the square root of 2 squared times 2 squared times 2 squared. The square root and the squareds will cross off. So at this point, I'm at 5 square root of 2a over 2 times 2 times 2. 2 times 2 is 4, and 4 times 2 is 8. So now I'm at 5 square root of 2a over 8. Now, there's a rule with simplifying fractions. If things are inside the square roots, you can simplify them, or if they're outside, you could simplify them. So I can't simplify this 2 and this 8, because this is inside, this is outside. If 5 and 8 could both be simplified, I could do that, because they're both outside the square root sign. But 5 and 8 can't be simplified, so this is my final answer. All right, everyone. Go ahead and try your homework. If you have questions, you can email me, or you could sign up for tutoring, and I'll walk you through it. Have a good day.